Doppler images and detect the largest Doppler shift using ultrasound, the transducer must be placed at an angle of 0 degrees to the vessel of interest. However, due to practical considerations, an angle of 60 degrees is used. Color Doppler can distinguish when blood is flowing towards and away from the transducer. When blood is moving towards the transducer, it is termed a positive Doppler shift and is represented as a red flow of blood on screen. A negative Doppler shift, where blood cells are moving away from the transducer, is represented as blue on screen. Different types of color Doppler also exist for use in cardiac and vascular ultrasound. Cardiac ultrasound primarily uses continuous wave Doppler. A continuous wave transducer is designed to be able to have one part of the transducer constantly producing a sound beam and the other part of the transducer constantly receiving the sound waves that are reflected back. Continuous wave transducers can also accurately determine the speed at which blood flows. Pulsed wave Doppler is primarily used for the rest of the vascular system, as the round-trip effect enables a greater accuracy about location rather than just blood speed. Whereas color Doppler is used to assess patency and blood flow, spectral Doppler, or spectral analysis, is used to quantify the amount of blood flow and resistance. Each part of the systolic peak represents the range of different blood velocities at a given time. The highest point on the peak indicates the maximum velocity. Most machines now automatically calculate velocity, resistance, and pulsatility. Power Doppler is more sensitive than conventional color Doppler for the study of small vessels which have low blood speeds, as it overlays Doppler information on a grayscale image and just shows the energy within vessels. It can also be used when unsatisfactory color Doppler images are obtained, as it is less reliant on the correct angle of incidence of the transducer.
just driving forwards. So, what's causing this illusion then? As you can see, the movement of the car seems to change direction.
Obtain a mid-long axis view of the common carotid artery using a high-frequency linear transducer. Activate color Doppler on the device and position the color box over the lumen of the common carotid artery, or CCA. The color bar serves as a legend that maps color to the velocity and direction of blood flow. Here, the red color indicates flow toward the transducer, and the blue color indicates flow away from the transducer. The intensity or brightness of a color is a representation of the velocity of flow. By convention, the display should be configured so that flow within arteries is represented as red and flow within veins is blue. The color bar can be inverted. This is generally done to display normal directional flow in an artery to be represented with red color. Adjust the color gain if necessary, so that color only appears in the lumen of the vessels, not outside of them. The normal CCA has a laminar flow pattern. This means that flow velocity in the center of the vessel is higher than near the wall of the vessel. Activate the spectral Doppler display mode. The spectral Doppler waveform enables the user to graphically visualize the velocity of blood flow over time. The system is dependent upon the user to set a number of parameters so that the correct result is displayed. First, the Doppler sample volume gate should be positioned in the center of the lumen, or in the area of highest velocity. Next, adjust the sample volume. The sample volume is the area of flow that will be represented in the waveform. The sample volume size should be set to approximately 1/3 of the vessel diameter. Another user configurable parameter is the angle correct setting, or AC. The AC corresponds with this bar. The purpose of this setting is to provide a correction factor in order to achieve the correct inclination angle. The goal is to align the AC bar with the direction of flow. The AC value should be in the range of 0 to 60 degrees for the carotid artery Doppler study. Obtain a numeric value for flow velocity by using the measurement tools. Freeze the image and place a measurement caliper at the point of peak systolic velocity in the waveform. The end diastolic velocity can be measured by placing the caliper at the lowest point of the trough just before